Hey, I screwed up. Uh, Either I need better eyesight or I need to always move the scope a bit closer. So, I did a bit more testing. So, there was a question about how I did the frequency on this mister. I've switched to a different scope simply because I can't get both of them on my big scope. So here it is hooked up to the output of the piezo. It's indicating 108 kilohertz, and that's only when it's on. It has a, if you watch the numbers, there's also an off cycle, which isn't displayed. So now I'm going to take the leads and show you how I did the other one, which indicated a much higher frequency. So in the other video, this is how I had it set up. I had a single turn, but on a single turn on here, it doesn't seem to want to pick it up. But with a double loop, it comes out to be about 105-ish, 100K, 108K frequency. And that's hovering over the chip. And if you go over to the inductor, get a much stronger signal and 108 kilohertz. And I think the frequency on the other one was about a 1 meg. So obviously this is not too accurate of a way to do it, but it does give you an idea. I think this was actually more accurate than the when I was using the other scope because it was pretty flimsy setup. But I'm now going to check it against the other scope. So now I've got it actually set up on the other scope, and I'm taking it right from the piezo lead. And have to wait till it cycles on. And it says 100.54 kilohertz. I wonder if I misread the display, because I said megahertz on the other one, and I think this is 100 roughly kilohertz. So that's set up like that. And then what I'm going to do is I'll do the loop with the probe. So here we have it set up with one coil above the inductor, and yes, wait for it. It's reading 100.4 kilohertz. So I'm starting to suspect I misread the megahertz. Should have been kilohertz. Now I'll just adjust it above the chip. So now I got the single coil directly above the chip, and it's reading 100.4 kilohertz. So if you just want to do a quick check on what the frequency is, do a single loop, hook up your probes, and then take a look at it on the scope. And obviously that little scope here worked fine also. And what you also need to do is improve your eyesight so that when you're looking at that tiny little number there, you read a K instead of an M. So I decided I'll try this also with a solar garden light. And with it connected directly across the inductor, though this might affect the frequency a bit, is 250 kilohertz. Actually, this little one's come in quite nice. Now I'll set it up with using a coil. And ditto. 255, 59-ish kilohertz. This was much more difficult to actually get, and I got, I think, about 2 and a bit loops there. But it does work if you want to have a component that you can't get clips on and you want to read the frequency of the inductor. It's one way to do it. Probably not the best. So that wraps this one up. Oh, the battery that came with this garden light, garbage. Barely holds a charge. Oh well, can't win them all. Have a good one.